In the last video I asked what might this h of x look like if it did not cut at x is minus 2 and x is minus 1. What if this dip that we have happened above the x-axis and we actually only got one point of intersection? Well, we can start off by taking out this x plus 1 and this x plus 2. They would not exist anymore. So we would have, let's cross those out like that. So we would have this x plus 3, and then we would have a new quadratic. We would have a new one that would be some a amounts of x plus, there's x squared, plus b amounts of x and plus c. So we'd have some new quadratic. And the way that I'm going to describe this quadratic now is the way that they're going to ask you, it's the kind of the basis that they're going to form the question on in the exam. Let me go down a little bit. So what I'm going to do is I'm going to bring in something new. I'm going to bring in the quadratic equation, which is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then I'm going to say that in this new quadratic where we have our a and our b and our c that fit nicely into this, what we would do with this normally is we'd say we're going to get two x values, one for minus b plus this lot and one for minus. So we're going to get two x values where this cuts the x-axis. But in this situation I'm going to say that in here, under this square root, b squared minus 4ac, b squared minus 4ac, I'm going to say that that is going to be less than 0. So these numbers, this a and this b and this c, are going to be such that b squared minus 4ac is less than 0, which means we cannot find two x values because the square root of a negative number won't give us anything. It'll just, if you put it in a calculator, it'll give you a math error. So what we can do, what we can say with this, is if we get a quadratic such that b squared minus 4ac is less than 0, then our curve is not going to have 2 points of intersection caused by this quadratic. Our dip is going to be above the x-axis. So the only point of intersection is going to be this x minus 3 here. So in the exam what they'll ask you, let me write this out for you. So they will say, show that h of x has only one real root. And this is getting away from polynomials a little bit. This is now a real root question. They crop up at the end of questions to do with other things. But it's probably quite useful that I show you this because it does come up on polynomials some of the time. So what you could say then, you could say that x plus 3 gives the root x is equal to minus 3, gives that root, and then you would say because b squared minus 4ac is less than 0, then no real roots can be derived from this quadratic. No real roots can be found in there. So that's why it has only one real root. So hopefully that's given you a bit of an insight into real roots to do with polynomials.